Hello friends, in this session we will see how to draw Nyquist plots in a traditional way. Why traditional way? Because it is very important in EAC exam or even in your university exams. So let us begin. So you have three steps basically. The first step that you have in order to plot this one is what? The first step is write down the open loop poles, write down open loop poles and open loop poles and open loop zeros in S-plane. This is the first step. It is a very easy step, right? It is nothing but our pole zero plot only, simple pole zero plot, right? Step number one. Step number two is what? Yes. Step number two is what? In step number two, you have to cover. What did I say? Cover entire right half of S-plane. How, sir? So yes, how to cover? You have to draw. You have to draw a circle of infinite radius. How that has to be done, I will tell you. Don't worry about it. Right? This is the second step. In this second step only, you have to write a note. What is that note? Note is that you have to bypass pole or zero at origin. What do you mean by that? I will tell you that. Don't worry. We will take n number of examples on this. Okay? Yes. And the step 3 is what? Step 3. It is map the contour on GH plane. First of all, student asked me, sir, what is the meaning of contour? Contour is what? Array, what you did just now. What did you do? You covered the entire right hand side of the S plane, right? That is nothing but contour. So from S plane, now if you see, you have drawn it on the S plane, right? So from S plane, you have to map it to something called as GH plane. What is that? I will tell you that. Don't worry, it is going to be very easy. If you remember, on GH plane we had also plotted something else, and that something else was polar plot, right? Yes. Okay, so now starting with the first example, if we see, let us begin. Let me take the first example. See dear, if you see, before that example, let me just ensure you about one thing. You may ask me, sir, why are we interested in the right hand side of S plane? Why? Because if you know that right hand side only gives you instability, if you remember, right? If you remember, poles on the right hand side of the S plane always gives you instability. So we are interested into the right half of the S plane. This is the reason, because we have to check whether there is any pole there or not. How to check that on all, we will talk about that later, but for time being it is okay, right? Let us take the first example. Yes, step 1 is what? Step 1 is very simple. Step 1, if you remember, it was just to draw a pole zero plot. Let me draw a pole zero plot. Step 1. So pole zero plot is what? Yes, it is going to be minus 1 by tau 1. This is one pole and another pole is minus 1 by tau 2. See, if you equate this one to 0, what you get? S tau 1 plus 1 equal to 0. So you get S equal to minus 1 by tau 1. Similarly, if you try this out here also, so you will get that particular pole to be minus 1 by tau 2. Yes, definitely. So the pole zero plot is available now, ready. Now the next step, what are we supposed to do? Let me do the step 2 here itself. Let me tell you how. If you remember, this is going to be S plane, this is S plane, right? So in S plane, here on the x-axis we have sigma, which is the real part of the S plane, and we have here imaginary part of S plane, which is nothing but j omega, if you remember. Yes. Now I want to tell you some things which are very very important. See, if you see, do you agree with me that this particular y-axis represents omega? Yes, it shows you omega. So here on the downside, if you see, if you just go below, 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 more below, you get minus infinity, right? Omega equal to minus infinity. Yes, this is omega equal to minus infinity. Similarly, if you go on the top, 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 so what you get here? You get omega equal to plus infinity. Is that correct? Yes, it is correct. Right. Now, what am I interested in? I have to cover the entire S-plane, entire right half of the S-plane, right half of S-plane, right? So, in order to do so, what will I do? Let us see. In order to do so, what will I do? Let me tell you. The first thing that I will do is, I will start from minus infinity and I will move up to 0. Is that all right? I will move from minus infinity and I will move up to 0, because here at the origin I know that omega will be equal to 0. Yes, so when I move from here to here, let me draw that this particular area, let me call that this is contour C1, contour C1, right? Is that all right? So if I try to show that, represent you C1, then you understand that C1 is what? C1 is the from omega equal to minus infinity to omega equal to 0. Is that correct? Yes. This is your C1 contour, right? Now, let me start moving from this 0 to positive infinity. What do I get then if I start from 0 to positive infinity then? Then this particular contour, let me call this contour as C2, and this is heading up to infinity, right? So if you think of what is my C2, C2 contour is what? C2 contour is nothing but omega varies from where to where. At origin it is 0 to omega equal to infinity. Is that right? Yes. Now, this is my entire imaginary axis. I have drawn everything related to this. It is done. C1 and C2 shows you that. Now, but you are interested in what? You are interested in entire right half of the S-plane. So since you are interested in entire right half of S-plane, what will I do is, I will draw a infinite radius circle over here. What did I say? I will draw a infinite radius circle over here, such that my entire right half of S-plane is covered. Is that correct? Yes. Now see dear, what did I say? This is infinite radius, right? So let me just mark the radius to be infinite. So this is radius r, which tends to infinity. Is that correct? Yes. Now, if you think of this contour C3, how to show this contour C3? This is very important. How to show that? See dear. If you remember, you have studied something called as complex numbers, right? There you must be aware of that a particular complex number, because see this particular S-plane, right? This is all S-plane. So if you see that in this S-plane also you have something real part as well as some imaginary part, right? So there you have seen that a particular complex number can be represented in the form of a exponential, in the exponential form, right? And that exponential form was z equal to r into e to the power I theta, right? Yes. Similarly, so in order to show this particular circle, what will I do is I will put I will show it by r into e to the power j theta. Is that correct? Why? Because I am saying that this capital R is the radius of this circle. I know it is going to infinity. So with this C3, if you see, it is what? It is r into e to the power j theta with r moving towards infinity. And if you think of this theta, what is this theta then? If you remember, we have gone this way, so this is c1, this is c2, so this becomes your c3. So if you see, we are going in this direction. Is that right? Let me show it with another color. So if you see, we are moving in this direction, this direction, this direction, which means what is that direction? If you remember, this is 0 degrees, then this is 90 degrees, and this is minus 90 degrees. So if you see, I'm moving from plus 90 to 0 to minus 90 degrees, which means theta goes from where to where? Theta goes from where to where? Theta goes from minus 90 degrees to 0 to, sorry, positive 90 degrees to 0 to minus 90 degrees. Is that right? Because this is plus 90, then we went up to 0, and then we came back to minus 90 degrees. So this was our whole journey of the circle, right? So here if you see, now you have this entire right half of the S plane along with the imaginary axis in your scrutiny, is that correct? Yes. Now step 3. What is step 3, dear? Step 3 is what? To map contour to GH plane. Contour to GH plane. How to do that mapping? Let us see. Let me firstly draw these contours. How were those contours? If you see, let me draw it here for simplicity. If you see, this was the S plane, this was sigma, this was j omega, right? Here I had these two poles. Is that correct? Yes. Now, if you check out, here was omega equal to minus infinity, and here was omega equal to infinity. So if we had started from here to here, we went up to 0, so this was c1. Then again we started from c1, we went up to infinity, so this became c2, right? And then we just closed it this way, right? So this was contour c3. Is that correct? And if you remember, I had told you that what is c1? C1 is what? It is from omega equal to minus infinity to 0. Then what is c2? C2, if you see, it is starting at 0 and it is ending at omega equal to infinity, so it is omega equal to 0 to infinity. And if you think of c3 is what? C3 is nothing but r e to the power j theta, where r is moving to infinity, and your theta is moving from where to where? From this point, from this plus 90 degrees to 0 to minus 90 degrees. Is that correct? Yes. Now let us draw the Nyquist plot. Let us see that. Let me call this plane as GH plane. So here I will be having real part of GH, as we already know, and here I will be having imaginary part of GH. Is that correct? Yes. If you observe, C2 contour is what? C2 contour is from omega equal to 0 to infinity. If you remember, omega equal to 0 to infinity is what? It is nothing but polar plot itself, right? Because we know that it is the variation of magnitudes and angles with respect to omega, which is varying from 0 to infinity. I hope you are aware about this. We have talked about it a lot, right? We have done total 5 parts on that, right? Yes. Anyways, so if you think of that, this one is the plot. So from the shortcuts, you can say that this particular plot, or if I may just start with it, then let us try to see those specifications for the polar plot. How to draw the polar plot? We had the 4-step method, right? What was that method? Step 1 was what? Step 1 was to find m0 and m infinity and all, right? But then what you have is you have gh, which is equal to 1 upon s tau 1 plus 1 into s tau 2 plus 1, right? So you are interested in gh of j omega, right? If you think of gh of j omega, it becomes 1 upon j omega tau 1 plus 1 into j omega tau 2 plus 1. Is that correct? Yes. Now if you think of the magnitude, how much is the magnitude? How much is the magnitude? It is nothing but 1 upon under root of a real part squared plus imaginary part squared, so it becomes omega squared tau 1 squared plus 1, right? Into what does that become? Under root of omega squared tau 2 squared plus 1. Is that correct? Yes. Similarly, if you think of phase phi, it is equal to what? It is equal to what? Tan inverse of what? Omega tau 1 by 1, right? Minus tan inverse of, minus again you have this tan inverse of omega tau 2 by 1. Is that correct? Yes. See, so if you see, we have talked about it a lot. So this is for the first and last time I will be explaining you how to draw the polar plots, because we have dealt about it a lot in our previous sessions, right? Yes. So now the step one is what? Step 1 is nothing but to find m0. How do you find m0? M0 is what? Magnitude at omega equal to 0. How is it? It is nothing but what? If you just replace here by omega in this magnitude, if you replace it by 0, omega by 0, so you get 0 plus 1 into under root of 0 plus 1, which is nothing but what? 1. So m0 is equal to 1. What about m infinity? M infinity is nothing but magnitude at omega equal to infinity, which is equal to what? 1 upon under root of, if you think of this, becomes infinity into again infinity plus 1, infinity plus 1. So this is nothing but 0. Is that correct? Right. Now if you think of step 2, what was your step 2? Step 2 was nothing but angle, right? You had to find phi 0 and phi infinity. What is phi 0, dear? Phi 0 is what? Phi at omega equal to 0, which is equal to what? Minus tan inverse of 0, minus tan inverse of 0, which is equal to what? Which is equal to 0, right? Then what is phi infinity? Phi infinity is what? It is nothing but phi at omega equal to 0, which is equal to minus tan inverse of, what do you say? Infinity minus tan inverse of infinity. If you see, tan inverse of infinity is 90 degrees. Tan inverse of infinity is 90 degrees. So minus 90 minus 90, you get minus 180 degrees. Is that correct? Yes. What does this mean? Now step 3 is what? Step 3 is to find this ending direction, right? Step 3 is what? To find ending direction. How to find that ending direction? It was nothing but phi infinity minus phi 0. What is that? Phi infinity is what? Minus 180 degrees minus 0. So it becomes minus 180 degrees minus 0, which is nothing but minus 180 degrees, which is negative. This means that ending direction has to be, how much? Has to be clockwise. Is that correct? Yes. Ending direction has to be clockwise. Now what is step 4? Step 4 is nothing but starting direction. Starting direction is what? Starting direction is what? It is nothing but you have to draw the pole 0 plot, which is this way, you already know. And if you see that you have this pole closer to the origin, which means that starting direction has to be also clockwise. Is that correct? Yes. So if you see here, my polar plot starts at 1 and it ends up at 0, right? Yes. How do you know that? Because m0 is 1 and m at infinity is 0. Now angle at omega equal to 0 is 0, right? That is the reason it is here 1. Now angle at omega equal to infinity is what? Minus 180 degrees, which means here itself, right? Now it has to either go in this way or in this way. See, I will explain you. See, Ending direction is what? Ending direction is clockwise, which means definitely it has to move in this particular direction, clockwise direction, right? Yes. Now if you think of starting direction is also what? Clockwise. So yes, definitely this has to be clockwise, so this has to move this way, right? So if you join these two, you get the polar plot. This was the polar plot, and if you remember, this is nothing but what? This is nothing but your contour C2, which is mapped from this S plane, this particular contour C2. Let me take another color. This particular contour C2 is mapped from S plane to GH plane. I hope it is clear to you, right? If you see C1 is what? C1 is from omega equal to minus infinity to 0, right? Now I will tell you one thing. If you see here, since it is starting, since my plot is starting here, which means here omega equal to 0, right? And here omega is nothing but infinity, right? Now if you see, what is this? They are saying that from omega equal to minus infinity to 0, omega equal to minus infinity to 0, it means that you have to take a mirror image of this like this. So this becomes now omega equal to minus infinity, and this becomes omega equal to 0. Is that clear to you? Yes. Now this is nothing but contour. This is nothing but your contour C1. So if you see, C1 has been drawn, has been mapped, and also C2 has been mapped. Now I am interested in mapping C3. How to map C3? That is the question, right? So if you see, it is nothing but r into e to the power j theta. So what will I do? Now see, you have to map this in what? You have to map this in GH, right? So very simple. What will I do is, what is your GH, dear? GH is what? 1 upon S tau 1 plus 1 into S tau 2 plus 1, right? What will I do? I know that in S plane I have a contour which is r into e to the power j theta. Is that correct? Yes. Now I want to map this contour onto GH plane. So I will simply replace my S by r into e to the power j theta. So if you find GH of r into e to the power j theta, which means wherever you have S, you please replace it by r into e to the power j theta. So after replacing that, you get r into e to the power j theta into tau 1 plus 1 into again r into e to the power j theta into tau 2 plus 1. Is that correct? Yes. If you see here, in place of S, you have just replaced r into e to the power j theta. In place of S, you have replaced r into e to the power j theta. That's it, right? Now if you know, if you remember, my r, where is that? Yes, if you see, my r goes to infinity, right? R tends to infinity. So if my r is tending to infinity, what happens then? What happens to the magnitude? Let us understand. R tends to infinity, which means what? This becomes infinity, this becomes infinity. So 1 by infinity into infinity is nothing but all 0, which means magnitude is going to be 0. What about angle? What about angle? If you see angles, how was that angle? Angle was nothing but plus 90 degrees to 0 to again minus 90 degrees. Is that right? Yes. Why? Because here we have already seen that theta varies from plus 90 to 0 to minus 90 degrees, right? Yes. So what do you understand from this? You understand that contour contour C3 is mapped, because see, it is 0 in GH plane at some angle 90 degrees to minus 90 degrees. It's okay even if you take other way around also, right? Because magnitude of C3 in your GH plane is going to be 0. We have seen that, which means it will be mapped in GH. This entire C3 contour, which was there, it will be mapped now in terms of a single point at origin. So this is going to be your contour C3. This is going to be your contour C3. So this ends your Nyquist plot for 1 upon s tau plus 1 into s tau plus 1. Is that correct? Yes. Now second example. Let us take second example. Yes. So the first step is what? Step 1. The first step is what? To draw the poles and zeros in S-plane. Is that right? Yes. So if you see, one pole is at origin, so I will draw it here, and another pole is at minus 1 by tau. Is that correct? Yes. This is sigma, this is j omega, this is your S-plane. Is that correct? Now I am interested in now step 2. Step 2 is what? In step 2 we try to find the contours, right? How to find those contours? Let us see. If you see here, from minus infinity, see, this is omega equal to minus infinity and this is omega equal to infinity, right? So from minus infinity to 0 I will be having one contour, right? Minus infinity to 0, so this becomes one contour. So what is contour C1? C1 is what? Omega goes from minus infinity to infinity. Is that right? Yes. Now second contour is from where to where? Omega equal to 0 to omega equal to infinity, so it is going to be my second contour. So contour C2 is going to be omega equal to 0 to infinity. Yes, this is going to be contour C2. This was my contour C1. Now I have to draw a entire S-plane, right? Now here you have to understand one thing. What did I say? What did I say? See, this particular C2 is going to be wrong. I have done it very intentionally to show you that students do such mistakes. If you see, if you remember, I had told you one thing, that bypass any pole or zero at origin. If you remember that, I had told you, right, that you have to bypass any pole or zero at origin. But if you see, we have drawn this C2 directly. Is it right? No, it is absolutely wrong. So what am I supposed to do now? I am supposed to do it this way. I will show you what. Right? Now, see, let me just erase this C2. This is wrong, right? We have seen that. How to bypass? Let us see. This is from minus infinity to 0, right? Yes. Now, in order to bypass it, you will do just a simple bypass this way, and your direction will be this, right? Because you are always starting from minus infinity. And now, do you understand that this is also a contour? Yes, it is a contour. So since it is a contour, let me call that as C2. Is that correct? Yes, definitely. Now if you think of C2, what is C2 here? What is C2 here? Let us understand. This is very interesting. See, if you see C2, is it a circle or not? Yes. So what is the radius of this circle? This is the radius of the circle. Let me call the radius to be R, right? And this particular radius, if you see, this radius R is tending to 0. It is a very small radius. It is a very small radius, which means it is tending to 0. So C2 is what? C2 is nothing but R into e to the power j theta, where R tends to 0. I hope this point is very clear to you. Now angle. What about the angle? See, if you see, this is 0 degrees, then this is plus 90 degrees, and this is going to be minus 90 degrees, right? Now if you see, I am moving in this direction. If you see C2 direction, it is from minus 90 degrees to 0 and then again to plus 90 degrees. Is that right? See, again it is from where to where? Minus 90 to 0 and again plus 90, which means theta varies from where to where? Theta varies from minus 90 degrees to 0 to plus 90 degrees. I hope this point is very clear to you, right? Now if you think of contour C3, Contour C3 will be where? C3 will be from again 0 to, because see, now student may ask me, sir, but it is not exactly equal to 0. Yes, I know. It is not exactly equal to 0. But if you think of this R is what? This is tending to 0, which means it is very, very close to 0. Not exactly 0, but it is very, very close to 0. Right? So I can say that even this is 0. So this goes from 0 to positive infinity, and this is contour C3. So what is C3? C3 is what? C3 is what? It is a contour where omega varies from 0 to infinity. Is that clear? Yes, it is very easy. Now, what about C4? Is there any other contour left? Yes, because you have to cover this entire right half of S-plane also, which means you need to have one more contour, which is C4. What is that contour C4? As usual, we know that it is also going to be, because that radius is going to be R, this radius is going to be capital R, which tends to infinity. So it is going to be what? C4. C4 is going to be R into e to the power j theta, right, where R tends to infinity. And what are the angles? The angle, if you see, the direction is this way, which means it is starting from plus 90 degrees to 0 and then again to minus 90 degrees, which means theta varies from where to where? It varies from 90 degrees to 0 degrees to minus 90 degrees. If you see, if you observe, here theta varies, the small theta varies from minus 90 degrees to 0 to positive 90 degrees, whereas here theta varies from positive 90 degrees to 0 to minus 90 degrees. I hope you are understanding this point. These are very, very small points, so it is very, very important. Now next, let us see how to map all these from S plane to GH plane. Let us see that. So if you just see, your C3 contour is what? It is from omega, which is equal to 0 to infinity, which means it is nothing but what? It is nothing but what? Polar plot. So let me draw the polar plot. If you remember, we have taken this question GH equal to 1 upon S into S tau plus 1. So I already know the plot for this. So the plot is going to be how much? See, this is real part of GH and this is imaginary part of GH. Okay, yes. So dear, if you see, contour C3, which is from omega equal to 0 to infinity, is nothing but the polar plot, right? So the plot for this, we know that it is going to be from here to here. We have done n number of examples on this, so I hope that you all know how to draw a polar plot, because now we are interested in finding out the Nyquist plot. You already know how to draw a plot. Now we are interested in finding out how to draw a Nyquist plot. I hope it is very, very clear. So this is going to be omega equal to 0. It is going to start here, and this is going to be omega equal to infinity. Is that correct? Omega equal to infinity, and this is the polar plot. And what is the contour? This is representing contour C3. This is representing contour C3. Is that correct? Yes. One battle is done. Next is what? C1 contour. If you observe C1 contour, C1 contour is what? Omega equal to minus infinity to 0, which means exactly reverse. So I am going to have a mirror image here this way. So this becomes 1, right? So this is another one, which is this way. Now always remember, Nyquist plots are always continuous in nature, Why or how? If you see, always the direction has to be followed. You cannot keep that this as upwards and this to be downwards. You cannot do that. This is very, very wrong. Okay. And if you see, it is showing you contour C1, right? So this is showing contour C1. So C3 is done and C1 is done. Now I am interested in C2. How to draw C2? That is a great question, right? Let us see that. What was your C2? C2 was nothing but R into e to the power j theta, whereas this was smaller, right? And we saw that R tends to 0, and this theta which is there, it is varying from where to where? It is varying from minus 90 degrees to 0 to positive 90 degrees. I hope you all know this, right? Now, if you see that again, yes, r and theta are the variables. So let me just do so. So if I just replace them in GH, if you remember, our GH was what? GH was 1 upon S into S tau plus 1, right? This was our GH. Now, if I replace R into e to the power j theta, what do I get then? I get GH of R into e to the power j theta, which is equal to 1 upon R into e to the power j theta multiplied by R into e to the power j theta into tau plus 1. Is that correct? Yes. Right. Now, we know that R tends to 0. Yes, R tends to 0. Which means what? Which means what? How much is the magnitude? How much is the magnitude? Let us find. So, for that, if you know that from your mathematics, you have already learnt that in such a cases while applying limits, because this is nothing but limit as R tends to 0, 1 by R into e to the power j theta multiplied by R into e to the power j theta into tau plus 1, right? So, you have seen that this particular term can be made 0. Here you can put r equal to 0. Yes. So if you see what it becomes, what you are left with is limit as r tends to 0. You have got this 1 upon r into e to the power j theta, right? So if I can show it this way also, that it is limit as r tends to 0, which is nothing but 1 by r into e to the power minus j theta. Yes. So now this indicates what? This indicates that your magnitude is this limit as r tends to 0. This is your magnitude 1 by r, and angle is what? Angle is what? Because of this minus. If you see, when your e to the power j theta goes on the top, this sign changes to minus j theta, which means now I am going to have this angle to be minus theta. This is nothing but the polar form. Already you have learnt it in mathematics, right? Yes. Now see dear, if you put r tending to 0, which means if you replace here r as 0, what you get? You get 1 by 0. So you get magnitude to be equal to infinity, right? Yes. And if you see, what about the angle? What about the angle? Just see. Just see. This angle is minus theta. It means that in your S plane, your theta was varying from minus 90 to plus 90. But now in GH plane, your theta is going to vary from plus 90 degrees to 0 to minus 90 degrees. I hope you are understanding this point, right? So if you see, plus 90 degrees to 0 to minus 90 degrees is what has to be the traversal, and if you see how much is the radius, then the radius is going to be infinity. I hope you are understanding this point, right? By the way, this is not a bigger one, it is rather smaller 1 by r tending to infinity. I hope it is very clear, right? Yes. Now, rather, I can show it this way also. Mod of 1 by r tending to infinity, right? Yes. Now see dear, what about C4 contour? By the way, this is C2, right? This contour is C2. So you have successfully plotted C1, you have successfully mapped C3, and you have successfully now mapped C2 as well. So C2 is also done. Now, how to map C4? How to map C4? Let us see that. C4 is what? R into e to the power j theta, right? So if you see C4, C4 is what? R into e to the power j theta, where r tends to infinity, right? Now yes, similarly, if you just think of what you have is GH is equal to what? 1 upon S into S tau plus 1. So yes, similarly you have to find GH of R into e to the power j theta, which means you please put S as r into e to the power j theta. If I put it to be j theta, r into e to the power j theta, what I get is r into e to the power j theta multiplied by r into e to the power j theta plus 1 into tau plus 1. Is that right? Yes. Now you know that r is tending to infinity, which means this becomes infinity, this becomes infinity. So which means it is nothing but 1 by infinity, which is equal to 0. So yes, this particular contour C4 will be mapped in GH plane at origin. So this becomes your C4. So this is your Nyquist plot. I hope you have understood the traditional method to draw the Nyquist plot. In the immediate next session, we will see the shortcuts. Why? Because if you see, it is very time consuming. You have to do so much of stuff. You have to do this r into it to the power. You have to do many things. You have to do many things. So to shorten your steps, we will talk about shortcuts in the immediate next session. Till then, thank you.